Terrific. Okay, so I'm just going to prepare a little bit here and to focus on model data collection and output. Okay, and specifically, we're going to be going and looking at collecting different types of data from a model. And what better way to do this than to get you doing some more sit-ups? We're going to go, so I used to in my boot camps have us reuse a lot of models we created earlier, and that saves time. But the problem is it doesn't get your abs in shape, so to speak. And it also doesn't, it also leaves open problems when people who tried to build those models earlier had a mistake, or they changed it later because they were playing around with it, and something weird happened, and then they can't use that model, and it causes trouble. So let's work on our abs. Okay, so I'd like you in the final day of the boot camp, I'd like you to go help me build up a simple model that we've seen before, and it's a model of infection spread over networks. Okay, it's one of my faves. Okay, so how do we create a model? I've been sitting here talking too long, and it's your time to talk with me. How do I create a model? Okay, new model. Okay, yeah, maybe some of you have almost forgotten now. This is my fear. Flexing the muscles. Okay, so this is going to be simple SIR model NC2. Okay, we've done this before. For those who have this before, if you want to peek at it, I won't be averse. But it's good to exercise this. Okay, so I have this model. What do I do? It's staring at you, just like it will be in your office after I leave. It's staring at you. Okay, we want to add an agent type. Good. Yeah, I am trusting that there's no cage being prepared to keep me here. So is that what all that construction noise has been outside? You're gonna have the cage Canadian or something? Okay, so it's going to be like the Sasquatch of the North. Okay, so we're going to create a person, right? And then we want to put that person to have an appearance. We want to lend them a face. Okay, good. Spherical cow. Is there a person shape that has flexible circle? I mean, yeah. It's nice that there's circles. You showed an example yesterday about people going into a clinic and they're changing, and with the circle there are so many features you can actually change. Can you do such a thing with a person? You can. The reason I avoid person. Can I speak to that? The basic deal is that with the person, with the circle, you can set radius really easy. You can set the thickness around them. You can set their color really easily. With the shapes unpack into okay. This is kind of. I wish I could simultaneously record this nugget. I'm gonna try something outre. I'm gonna try recording a nugget atop of this. Oh man, I'm scared. It's recording two things at once here. Okay, I don't know if this is going to clash. I'm afraid they're going to be writing temporary files to the same place, and bad things are going to happen. But you got to. Sometimes you got to. Nothing ventured, nothing gained, right? So let's drag in a person here to person, and let me show you in concrete terms what I mean. Okay, so this person that you see, it's actually what's called a group. It's actually, in this case, it looks like, I guess in AnyLogic 7, it's just a single sort of line wrapped around. And And so it looks like actually here you could set the line color, okay, and you could set the scale. You can't set the, no, it looks like you could set the fill color. So let's set the line color to be red. Aha. Okay, so that's pretty good. That's pretty good. Should we use this instead? Yeah, let's use a more anthropomorphic rendition. I used in pictures. I used the person one. Now, some of my more mischievous students have been known to employ, for representations, particularly of those with MDs, they've been known to employ fighter jets, and they've also been known to employ pictures of myself in some representations, but that's the most unseemly activity, and one of which Priesri is innocent. Yeah, it's not a fighter jet. Stop looking at that. It's person here, right? It's person, and we dragged it in, and we can independently set it looks like the line color and the fill color. I think this has been evolved from AnyLogic 6.5, where I was last probbing it, and so it looks like we have the requisite flexibility to do good things. Okay, we could set the scale, we could set their shape, the shape around them, and we could set the, and so there's an application that has the requisite flexibility. Okay, hey, okay, okay. Yes, yes, yes.
And I hear a little rumbling, so I'm wondering how much is having this. I tried to push it in, but I don't see the option to change color and line and stuff.
So if you select it,
I've got the shape selected.
And
oh, now I did. Okay, somehow I must have done it different. Yeah, okay, got it. Now I'm good. Sorry about that. Yeah, I thought I had it. It was like, anyway, yeah. I thought I had selected very much.
Yeah, you have to, thank you very much. What I did originally is I went over here. Oh, this is a general point. Man, I've got too many nuggets going on at the same time here. So let me nuggetize this guy. Okay, so this guy is availability of flexible animations, flexible anthropomorphic animations. Morphic animations. How's that for alliteration? Okay. So the other thing I want to speak about is so these little animations, they come in several pieces. Well, in general, when we have things here on the screen, I often find it's more precise to go over to this left-hand side, the projects, and go open things up and select them. So you could try to select things by double-clicking on it here, but I have trouble sometimes with that, and I find it easier to just click over here, like on Shape Body. Now, the thing that I was warning about before is that some of these other animations have many pieces to them, so they'll not have only one thing under it, like Shape Body. They'll have many things, and then each of them can be colored separately, and it gets confusing about, oh, I'm only coloring the head, and oh, we're only reaching the head of the person, and their body is going to be still the same color, and it's not so clear what the coloration is. But here it's pretty clear, and I'd say let's go with it. Okay?
But Nate, in this piece, if we want to programmatically or in the model change, say, the fill color.
Yes.
Are we going to have to refer to person.shapebody?
Yeah, I think it'll. This is a good question. I believe it's person.shapebody. Let's go see. So let's go say on startup. What's the person? It's called shape body. Yeah. Shape body. Okay. So the actual person itself. Yeah. It's okay. So that's interesting. Let me think about that here. This person.shapebody, person.shape. No, it looks like it would actually just be shape body. Okay. This shape body. Yeah. Great question. Person just is a name for the group of them. But in this case, there's only one member of the group, so it's just shape body. Yeah. Okay. So great question. How do you refer to that? You'd refer to the shape body. Okay. Okay. Great. So let's stop nuggetizing because this is taxing my machine's resources. Okay. So this is going to be notes on selecting on animation selection and properties and referring to the animation. Okay. Okay, great. So moving right along, let's go now. Let's go and create a population of people. So how do we do that? Drag a person into main. We're going to create population. Remember, there it shows up there, population. Up here it shows, I believe this is going to be basically the origin for where it will stay. This is 0, 0 with respect to person's display. Okay, for the population, how do I turn this into a population of size 100? Population of agent, size 100. Okay, great. Great. Okay, so suppose we now want to put these people to be randomly laid out in space. We're going to have a closed population. We don't have to worry about people coming in. Where can we do that? How do we lay them out in space? Main? Layout type random. If they were coming in over time, where would we go? Go to population and set the X and Y coordinates for it. Here we can lay them out randomly. Okay, let's run it. Build early, build often, and run. There we go. Somehow my leg got damaged. The left leg and my man got, or my person got damaged. I don't know why. Okay. I think we must have frobbed it when moving it around. We must have damaged it while interacting with it. Okay. So in any case, assuming that it's laid out randomly, anyone need TA help? Free S3 stands ready. Okay, TA deploy to sector 3. Okay. So now let's put these people in a network. Pre-S3, we are doing the SIR exercise. Okay, so you can, yeah. So how am I going to put this person into a distance-based network? Where do I go? Main. Okay. Main and network type. Yeah. Okay. What sort of connection? Distance-based. Connection rate 75. Okay. Is that the headless person? Yeah. Oh, okay. She what? She had a Batman? Oh. Well, I won't object. Okay. Why aren't we seeing the network? Is there a network? There is a network. Oh, why is it hidden? We have to draw the connection. Okay, good. So tell me where to go to draw the connection. Good. Person, and then connections, and then we have to go down and do animation. Okay. Man, I see some pretty good muscles in this room. Okay. Great. So here we have people in a network. Even if they're headless people, that's okay. 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 Great.
I'm having trouble finding that.
Okay. So go to person, connections, and you scroll down to the animation section, and there's a checkbox. Draw a line. infections are visible, right?
Oh, I'm sorry, of course, yeah, I remember, I had this problem.
Yep.
Good thing.
Okay. Okay, great. So now we have people on a network, right? Okay. So we're building these muscles, okay? We're a lot of the way there. Now we want to. Now it's our pull-ups exercises. Okay, we're going to be doing. We want to impose now a state chart, and it's going to be an SIR state chart, and we're going to have probabilistic infections. So when people are exposed, they only have a certain probability of getting infected. As there's 3 states. We won't do a full SEIR. We'll do a 3-state SIR. Okay. So what do I do? Go into where do I drag it in main? Okay, person. Good. Good. Okay, drag in the state chart entry point. Okay, state chart. We'll call it I don't know, infection state chart, right? Something like that. And then we'll add a susceptible state. Okay. An infective state and a recovered state. Okay. Yeah. Okay. And we're going to have a set of transitions. So it's going to be a pretty vanilla thing. We're not going to have loss of immunity, but a state of transitions. So one is going to be from infective to recovered. Now, one from susceptible to infective is going to have a branch in the middle of it, a branch reflecting that exposure is not automatically going to infect someone. So we can space these out a little bit, okay? Now, well, I already let the cat out of the bag, but how are we going to capture a probabilistic infection given exposure? We're going to have a branch. Good. Good. And we're going to drag a branch over here. Okay. And then we're going to have a transition into the branch from susceptibility, reflecting exposure to the idea or the pathogen or the behavior or what have you. And we're going to have one transition going back. You could do it nicely with by double-clicking on it and throbbing it. Ladies and gentlemen, riddle me this. What sort of transition will it be from susceptible to the branch? It'll be a what? Will it be a rate transition? Will it be a condition transition? Will it be an on-arrival transition? Sorry? It'll be a condition? Not the one I have in mind. For the SR where they're getting infected by each other over the network, we represent exposure by what? A message. Okay, so what sort of transition will it be? A message transition. Good. 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 Okay. You've completed 10 pull-ups already. So this will be we'll call it exposure, and I'll show the name, sure. You notice in general, it's not going to be able to tell us the time until next exposure. If we're watching the tick down, even if we say show name, it's not going to be able to tell us because that's based on a message, and that's not something you can predict when the next message will come in. Can't draw that from a distribution. That's a sort of asynchronous event. Boom, it'll be sent. Okay, exposure. Okay, great. We're going to have then a probability. We want to capture a probability, and this will vary between people, between individuals. A probability of exposure, of infection given exposure. Okay? So how are we going to encode that? With a what? Parameter. Yeah, thank you. Probability of infection given exposure. Ladies and gentlemen, as I'll highlight later in the day, naming is important. Give thought to your names. If you call something P, others will wonder what is P when they look at the model, and you 6 months from now may wonder what is P, especially if you use P on a regular basis to mean very different sorts of things. It's better to use a name that's more descriptive, whose intention behind it is clear. Okay, So I tend to be a little bit on the loquacious side. This could be prob of infection given exposure. And maybe some would even make it prob of inf given exp. But at some point, it starts to become more opaque to those who are looking at your model, even if you have certain conventions. So name matters, you can think about the name correctly, but it matters in the human theater of things. It matters for your stakeholders. It matters for the confidence they build about your model when you show it to them, whether they can understand it. And if they can relate to it, they're more likely to be open to it. So pay attention to names. Okay, so the probability of infection given exposure, where would that go in our model? Where do we use that? Okay, coming out of the branch. So this might be infection transition, and to use that probability, what would we make it? Would it be default or condition? Condition, and what would the condition be? Random true with that probability. In other words, that we'll flip a coin, and with a certain probability, it will be true. This condition is looking for a true or false. Is this going to fire or not? And this will determine whether it's true or false. With this probability, it will be true. Otherwise, it will be false. Does that make sense to people? The name of the probability that we just created. Yeah. Does that make sense? Who needs TA help? She sits ready. Okay. How about this return one here? What sort of thing is this return transition? Default. There can only be one default, remember, but this is an example of default. Great. Okay. And then we're going to have another parameter, which could also vary duration of infection, and we'll assume that in this case this is treatment mediated. So in other words, a longer duration will often be an indication that we haven't found a person quick enough. Think about STIs, things like gonorrhea, chlamydia, and certain other bacterial STIs such as syphilis, as well as viral STIs such as herpes, where there's an important treatment implication for duration of circulation with infection. This can be duration of infection, and we want that that's a mean duration of infection. So I probably should say mean duration of infection. And suppose we're going to make the assumption that it's a memoryless process. So we have a certain chance per unit time of recovering that's independent of the duration of the infection. We could make it a timeout, but let's have it be a chance per unit time of recovery, regardless of how long you've been infected. What sort of transition would we use for that? A rate transition. Good. So this is recovery. I should really be showing these names so it's more transparent for those looking at the model. I see. I was selecting the wrong thing. Show name. Okay. That's misspelled. Infection. Okay. So this will be a rate transition. What would the rate be? What's that? It'll be 1 over the mean duration of infection. Yeah. So if you have a mean duration of infection of 10 time units, this will be 0.1 per day chance of recovering. That just arises from the properties of the exponential distribution, and it can be shown by integration by parts. Okay. So that's great. As a general rule, folks, I would get in the habit when you're going to write reciprocals or fractions, if you have a constant, make it a floating point constant to avoid the risk that by some mammoth oversight, well, it's not always an oversight, that you have something in there that's an integer, and you have this silly thing where it's like 1 divided by 3 is, well, 3 goes 0 times into 1, so it's 0. So get in the habit of writing 1.0. In this case, we don't need it because the mean it's a double double value anyway, but just get in the habit of doing that, of thinking a little bit about it, and you'll spare yourself grief in that occasional time where it's needed. Okay? Yeah. Yep. Yeah. So, oh, beautiful. So, do you want to pick a distribution? Would you like to pick a distribution? Let's do this. So I'll do a timeout. This is how we do it. Remember, timeouts can be used to impose an arbitrary distribution, and then maybe we want to go up to this distribution picker up in the upper right here. It looks like a little wizard's wand. Sorry? It's up here. Choose probability distribution. Okay. So we could do a beta distribution. Make it beta. Something like that. I can't remember what the beta is in terms of its distributions. Or a gamma. Yeah, so we could basically, if we wanted to impose an arbitrary distribution, you'd use a timeout and then just be explicit about what the distribution is. So maybe we won't afford ourselves with that flexibility here. But by the way, can I just show what would have happened if we had done that? Let's suppose we picked the beta with the default parameters here. Oh, let's put it here. We picked the beta. What would have happened if we said, yeah, this looks good, we say okay, it'll insert the code for it. This one was there before, but it'll insert the code. I want an Erlang distribution of second order, okay, and then it will insert the code for it. Okay, so remember, timeouts can be used to implement arbitrary distributions, to draw from arbitrary distributions. And this, yeah.
If we use the gamma, say, could we, for one of the parameters,
yeah.
Could we insert the parameter value, mean duration?
Oh, sure. Sure. Oh.
In this little pop-up menu that shows up?
No, you do it down here in the thing that's inserted. You can actually, in the pop-up, you can play with the parameters and see how it varies things. Yeah. Then it inserts the code, and then you put the parameter into it. Yeah, yeah.
Okay, so what are we going to do instead? We're not going to do.
So we're just going to do a rate with 1 over, just because. I mean, we could do an Erlang. I know for an Erlang, I could probably figure out what the mean is, but let's just do it this way for simplicity. Yeah. Okay. Great. Great. Okay. So I'm curious. The Erlang parameters that they have. Yeah, they have a shape parameter and yeah. Okay, fine. Okay. So here we have this, and folks, what are we missing from this? If we want to represent infection, what are we missing? The what? Nobody's sending a message. Okay, good. So where would we send a message, and how would we send it? Okay, we could do it with an event, but the easiest way to do it, if you have a state chart, is drag in transition here inside the infective state with a certain contact rate. So let's create a parameter called contact rate. Now, in these cases, I'm going to leave these open to be modified by an intervention. So I want to have each of them. So this would be contact rate. So this would be contact per day. Okay. Where would we set the time unit of the model to be days? Okay, it's the model. The model as a whole, we would specify time unit to be days. Okay, now for the contact rate, we're going to get that to go off with a certain rate, And the rate will be what? Suppose we have 3 contacts per day. What would the rate be with which this goes off? Contact rate. Yep. No trick question there. It's contact rate.
We have not defined yet, right?
I just dragged it in there as a parameter.
You dragged it in, or you created it?
Well, when I say I dragged it from the palette. Yeah. Yeah. Contact rate is going to be the other parameter we're going to specify, and this will be specified by it'll be associated with the rate transition here within the infective state. Can anyone tell me what does this mean? So we have that sort of transition. What does that mean? Well, while they're in that state, this is going to be happening, right? While they're in the infective state, you're going to be getting this contact rate firing at that certain rate, this contact firing. Okay, what's going to happen when that contact fires? We're going to, yeah? Good. So we're going to send a message. Okay. So I'm going to say this dot send to random connected, and I'm going to send a message. We did it before with enums. Do you want to do it with enums again, or do you want to just do it with strings this time? Okay, you want to do it with strings? Okay, we got to be careful. Got to be extra careful. So we'll send the message exposure. It'll spare us a bit of time, but it leaves it vulnerable in general. So if this were a real model, I'd do it with enums, with optionless. Okay, I'm going to send the message exposure, exclamation point. The key thing is we're going to need to handle that message where, folks? Where is that message going to be received? Whence? Sorry? Yeah, it's received in this transition here. And it's going to be on a particular message exposure. Exposure. Sorry, I don't need to. It's the message is exposure. It's got to be that exact same message. This is the problem with strings. We've got to make sure it's precisely the same. Okay? Okay, in that event, then this will be fired. Right? Does that make sense? Okay. Okay, we're getting close to done here. What final thing have we forgotten?
We need somebody to be infected.
We need somebody to be infected early. Okay? And just trying to cut down on time here. What are we going to send them when they're infected? A message. And what message is it going to be? Okay, suppose we send them an exposure message. What may happen?
Oh, they might not get
Might not get infected. So how do we be sure to get them infected? We'll use a different message type called force infection. Okay? So where would that message go? If there's a message which definitely infects them, where would that go? From where to where? The associated transition would go from to infective directly. So let's draw a parallel transition there. Okay? This is to make sure they definitely get infected. Okay? There we go. And this will be force infection, and it would be a message transition, and on the particular message, we're going to send the message force infection, exclamation point. Okay? Okay. Now, the final piece is what? Where do we got to send that Where do we got to send that force infection message? Yeah, main needs to send it. It needs to send it inside of itself. By the way, this is not the only way to do it. There's many other ways to do it. One other way is will be to create a branch when people come in. Some start infective. Some initially come into this state, and they would expose others. That'll be another way to do it. Okay. Another way, we click on a person and they get infected initially. Okay, great. So here we need to get main to send. Where would it send it? This is really good nice little example to touch on a lot of things. Where would we send it? On startup. Good. And this would be, it would be this dot, so that any agent inside can get exposed to the message. So does anyone remember the particular thing we're calling to do that? Okay, there is actually a send to random, but it's actually called deliver to random agent inside. Okay, deliver to random agent inside. It's on startup. Okay. And we need that exact message. Okay. Exactly. Let's do that now. Okay? So let's change colors here. Okay? So how do we change colors? Anyone? Okay, good. And a color of which guy? The shape body, right? The shape body, right? Okay. So suppose we want to change the fill color. We'll come back to the line color later. Suppose we want to change the fill color based on the current state. How do we do that? We could put in an expression, but generally we would, if we had 3 or more states, we could more easily use we could use a variable. Could use an option list as part of it, but so we'll have a variable called color. What's its type? It's other and then color. It's a specific color. Well, you folks have learned a lot. Okay, and in susceptible, what are we going to do to that variable? So again, I inserted a variable in person called color, C-O-L-O-R, lowercase, and its type is other, capital C-O-L-O-R. Okay. And where are we going to set it? Each place, that's right. So we're going to set it in susceptible, and let's set it to be green. And it's good practice, if you're going to do this, to set the state chart accordingly. So maybe we'll make it color equals lime, because the late state chart color, see how it says lime? It actually gives the name of the color. And then for the infective, I just copy and it's going to be yellow, and we're going to set it to be yellow. And then for the recovered, it's going to be gray, and we're going to set it to gray, G-R-A-Y. Okay? That's great. So we set this color variable to each of those colors, and we colored the appropriate state chart. Who needs TA help? Okay, two people need TA help. So I'll deploy to sector 1. You handle sector 2. Okay. Yeah.
Sorry.
Sure.
I just don't know what to see.
Sure.
Okay, so I just need to create the variable.
Yeah, and I would just call it color.
Okay. With a little c?
Yeah, with a little c. Good. Great. And then you go to susceptible. Oh, yeah, that's right. Folks, sorry, we should make infective red. Thank you.
Yep.
Thank you. Okay, so here you have to set color equals lime.
So little c,
yeah.
color.
Equals lime. Yeah, because it says lime there.
Yep.
And then infective, then color equals red, and the same thing. Okay, folks, this color for infective should be red. I screwed up. It shouldn't be yellow. It should be red, just to be consistent with kind of the interpretation. Okay, there we go. Okay, what's the final thing we have to do now to get this working? That's a good point. We should set parameter values. So that's one more thing. But the other thing we need to do is we need to set the shape body to use that color variable, right? Right? Does that make sense?
What type of color do you use? Sorry.
Color, capital C-O-L-O-R. So it should be other.
Thank you.
Yeah. Okay. And so build early, build often, and then make the shape body have a fill color given by what? Given by, yes, indirectly by the state, but what is it given by? It's by color. By color. By my color. You could say this dot color if you want to. Okay? Great. Uh-huh. Yep.
In person, I want to highlight just the person shape.
Oh, go over here to the left-hand side. It's much easier to do this way. So expand, expand this one, and then shape body.
Thank you.
Okay. Okay, folks. This thing here, make sure when you want to select that, make sure it's selected over here. It's easier than selecting on the right-hand side. Set the fill color to be this dot color. Okay? Okay. Great. Just about totally complete. Yes? Well, I'm about to go set that. It hasn't been set yet. So we're about to go set that. Okay? So the probability of infection given exposure here is going to be 0.04. The mean duration of infection is going to be 10 days, and the contact rate is going to be 10 as well. Okay, I'm sorry, excuse me. The probability of infection given exposure is 0.1. Excuse me, 0.1. Okay? 0.1? People okay with that? Okay, can we do this, and then can we run it? Okay. Okay. So there we go. We have the infection spreading. Okay. Okay, so basic things to work. Okay, so now we're going to use this model. We've built our muscles enough. Now we're going to use this model to actually do some new types of work. Okay? Yes? Can you determine how many people get infected in the first place? In the first place, meaning? Oh, it's delivered to random agent. It's a single agent. Oh, sure, sure. So there's a question from the audience as to whether, do you need me to select something here? Do you need me to show something?
Setting the parameter values, there's found a place where they were all available.
Yeah. 0.1, 10, and 10.
Yeah, I thought it was going into the person, into the parameter values themselves.
Oh, no. The person's one is just the default one. They're really specified at the population.
That's great.
Most fundamentally. Yeah. So the question was, can we infect more than one person initially? Sure, you could. You go to. So where's that initial person infected? Could you tell me? At the on startup of main. And so here you could have a loop that it picks the number of people to infect, and it loops over, from 0 to that -1, and it infects a random agent as a result. Is that helpful? Yeah. Okay. Okay. So any questions on this? Who needs additional help here? Okay. 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 So. Okay, so there's a couple of hypotheses I have. So this is exposure. Okay, are they sending an exposure message? Okay, this is the thing you need to do. So it'd be this dot send to, okay, control space, send to random connected. And you need to send that exact message. So quote, exposure, exclamation mark. Who else needed help here? Okay, I'll be with you in just a second.
Oh.
Okay, so what symptoms do you have?
Mine does not show any infected.
Okay, so I have two hypotheses. Okay, folks, watch how, if you're interested in learning something about how to debug these models, you might be interested in watching how I figure out what the problem is for people, because experienced computer people develop a method for sort of approaching it. So if a student shows me a problem, I want to see the symptom. I want to see the failure. What's the problem? So in this particular case, I have seen that the network is displayed correctly, people's colors are correct, but there's no spread of infection. In fact, no one is starting infected. So immediately my mind goes to several hypotheses about what could be going on. Some of the hypotheses are very minor and not too important. Things like, well, maybe the color isn't showing accurately reflecting the person's state. That's possible, but I immediately tend to focus on more likely hypotheses. For example, maybe there's a person, they haven't been initially infected, or maybe so no message was sent to them, or maybe a message was sent and it was ignored. So those are the first two things I'm going to check out, okay? So I'm going to go to your main, and I'm going to look, okay, so you have a message force infection that is being sent. So there's a message being sent, but somehow it seems that it's being ignored. Okay, I go here, and I see this is handling a force infection message. That's great, but maybe is this other one also handling it? No, both of them are handling the proper messages. Okay, so let's go this. We see color equals red. Okay, so here we're actually setting the color properly. Let's go look at this person. Oh, you're using a nurse. Okay, you're using a nurse rather than a person's appearance. I'm wondering if it's because
why does it have so many different?
It has. See, this is the problem with the nurse one. It has many pieces.
Oh.
And did you set it to use the color or no? To use that color variable?
Only this one is this color.
Oh yeah, you see that might not be very visible. So I would delete. Okay, what you need to do is do this. If you're going to use this, the simplest thing to do is to do it for all of them. Okay. So in this case, the nurse was actually not reflecting. The nurse picture was not reflecting the actual color. So it was my minor hypothesis proved correct rather than my major hypothesis. Okay. And keep on doing it for all of them. Okay, Shakiba, you need help?
I cannot change it.
Okay, so here's the problem with the color. So here, you're selecting it, but you can't see where to change color. So what you need to do is, in this case, visually you can't select it. You're holding it and you can't see that. What you need to do is in the project properties, you have to go over to person presentation and go into shape body, and then you can select that, okay? Okay, who else needs professor help? Okay.
I'm having exactly the same symptoms.
Okay.
There's no initially infected person.
Okay, so my mind immediately goes to several hypotheses.
So,
can I
sure,
take command? Okay, so let's go to main here. Let's see if a message is being sent. Okay, there's a force infection message. Is it the same one here, or does this have an exclamation point? No, that looks good. Okay, so it's handling that message. Okay, so why is it their color is not being set? Is that there? Yes, that is there. Okay, so let's go up to this guy. Let's go look at his shape body, and it's this color. Okay, so this is a very interesting case because it seems that the message is being sent, but it's being ignored. Okay, so let's check if the message is being received and handled properly. Let's get it to print out when it sends that initial message. Trace LN, I was forced into infection, okay? So if we do that, let's see now if it runs. Okay, let's go and run the simulation, and let's see if it prints out, okay? So I was forced into infection. So there is it being infected. The person. So let's do now a message. Let's take that same printout and let's do it when they come into this state, just to be absolutely sure this state is being executed. Okay, so we're going to run this now. Okay, run it, and here we go, and forced into infection. Okay, so they're recovering too quickly. Do you see? There are actually 2 people recovered there. So they are being infected. It's just they're recovering too quickly. What's your recovery time? It's 1 over mean duration of infection. What's the mean duration of infection here? Let's go take a look at it. Mean duration of infection is 0.1. That's this should be 10. The probability of infection should be 0.1. It's just you were using a different order than for me. So I'm going to run this thing, and let's go see if it works. Okay, there you go. Okay. Okay, folks. I followed. I'm going to talk more about this later, but the process I followed, I observed the symptom. I develop hypotheses for what might be causing it. I go and I check the hypotheses. Sometimes those involve checking code. Sometimes it's ambiguous. I insert statements that will print things out when things are happening to test hypotheses. So, for example, I say, I wonder if this person is actually receiving the message. I insert a statement when that message is triggered, and the action for that message will print out, I've gotten the message. And then I run it and see if that's been received. Based on this, I refine my hypotheses. Sometimes I'll test it under alternative conditions. The point is that when you encounter a problem, it's a hypothesis-driven, step-by-step sort of method to simplify the situation and further refine hypotheses based on observations. And that allows you to zero in on the situation. This process among professional programmers can differ in a factor of efficiency by about a factor of 10. And so it's worth, and a lot of the issue is that when certain programmers get exposed to a problem, they flail. They don't know what to do, and they sort of just try poking at it in various ways. If you have a well-defined process to follow, and I teach on this, and I'd be glad to send you, point you to videos of me teaching debugging processes, it'll be much, much, much quicker. You can find the solutions to your problems very quickly if you follow a defined process. So I'd be happy to send a link to recordings where you'll see me speaking about this. Ideally, I could speak about this today, but I think time is too short to allow it to be really fulsome. But I wish I could have shown you what I was seeing on each of the screens and how I zeroed in on the problems.
Could you make sure you add a link to that in the important references to the screen?
Sure.
It's hugely valuable.
Sure. There was a story of a close friend of mine who was born in upstate New York, and he had a brother, an older brother, who had an unusual name, and he had a grandfather who was they were growing up in a farm. It was a farming town, and the grandfather took the kid aside before he went to kindergarten and said, "Look, you have an unusual name. Kids are going to make fun of you because of that name, okay? So I'm going to teach you how to box, okay?" So this is not what I'd recommend. It's a technique, but he taught the kid how to box, and he was kind of, at first he was playing with the kid, and the kid was kind of, punching back. And then the father started a bit more aggressive and sort of going at the kid, and didn't know what to do back, and then he started to flail, and he started to go like that. And the grandfather grabbed him, and he said, "Look, Galen, you do one thing when one lesson to start with when you're learning to box, don't flail, okay? It's not going to help the situation to flail like that." And so it is with debugging. And all too often people flail when debugging. And if you can follow a clear step-by-step process with hypotheses driving things, and you're investigating the hypotheses and taking note on what you see, you can often beat the problems. Perhaps here they'd say lick the problems much more quickly than if you're just going at it in a scattershot way. Okay? So yeah, I'll see if I can insert a link to that. Okay. So now I think we're all in a good case. Who else? Is there anyone else that needs professor help?
I have a silly question.
Yes.
Wouldn't ask it so I don't spend time
okay.
You have to get lost. Are we only contacting people in our network?
Yes.
Okay.
Yeah, we're only only contact people within the, that's why it says send to random connected.
Got it, of course.
Yep. Okay. If it were sent to random, it would be everyone. Okay.
And you could send it both.
Correct. Okay. Okay. So now that we've built up those muscles, now we're going to take it in some unusual ways. We're going to use this model to collect information of very different sorts. Okay. The first thing we're going to do is to use a statistic to count the number of people that are infected. You folks have done this before, so this is a review. Where do we go to count the number of people that are infected? This is a simple cross-sectional statistic. How can we do that? Okay, population, and then go where? Where? Add statistics, and we'll do count infective, okay? Okay, count infective. Great. And this will be a count, and what will the condition be? What will the condition be? Good. And so how do we refer to that person as? No, it's item here. We're in Maine. This is referring to Maine. So item, that's what that little thing is telling us. Item dot infection state chart in item dot infection state chart dot is state active, and then you'll say person dot infective. Okay. Again, it would be more robust to be able to just have a function that says is infected, and then you just call the person's function item dot is infective, and that function would know how to determine if they're infective. But here we'll do it directly. Okay? Yeah, sure. With control space. Yeah. Sure. Yeah. And again, you could do control space for that. Yeah. Person dot infective. And again, control space is your friend. It'll autocomplete. Okay? So this is sort of the simplest form of statistic. We've seen this before. Okay? Okay. Great. Okay. This is a cross-section. What's that? Oh, count infectoid. Thank you. Okay. Okay. Now, one virtue of a statistic, as we've seen it before, is that it'll provide immediate feedback. We can click in here and we can see the count of infected. That's nice. But a statistic is limited in what it can do for many reasons. One, it involves a complete pass over the population. And if we're classifying people, say, into age categories, we're going to be doing a complete pass of the population to count the number that is 0 to 4, and then a complete pass 5 to 9, complete pass over the population to 10 to 14. It's fairly inefficient. It's also limited to cross-sectional depictions. We can't really do this to ask how many people got infected in the last period of time. We can't ask it to elicit longitudinal information on an individual. So we're going to now explore some additional features for doing that. But first, I want to create an output mechanism. So we've seen how to collect this data. How can I create an output chart that will display this data? Anyone? Where do I go? Yeah, I go to analysis, and we're going to put it on main. Yep, we can put charts on a person if we wanted to, but in this case, we're going to put it on main. It's important to realize you can do that. You have the flexibility to do that. Okay, we're going to put it on there, and then how are we going to, so this is going to be plot infectives, okay. A time plot. Time plot. Then I'm going to do add data item, and I'm going to plot out a value, and the value is going to be what? How do I call that statistic? Okay, population dot count infected, the name of that statistic, which I filled in. Make sure you filled in that name or else it won't be listed. Important thing here that I want to bring home is when you define a new statistic, it inserts a new method, a new function into that population that you can call, okay? That's find count, okay? Okay. Who needs professor help? Okay. Okay. Uh-huh. Yep.
I'm not saying this isn't available.
Okay, so go to, so my hypothesis is maybe the statistic is not named. So go to the population and scroll down to statistics. It's a very common error. You left it as population stat, so that has to be named. Okay. 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 So anyone else having trouble with that? The little, you mean the magnifier? Yeah. This guy. This guy here, and this guy here. So it was item.infection state chart.isStateActive. And again, for most of these, you should be able to do control space. That's in the count, and it's called count infective. Okay? People okay with that? Okay. Got effective. Okay. The now the chart is we did add a data item, and we called population dot the name of that statistic, count infective. Does that make sense? Okay. So run. Make sure it works. Then we're going to be going on and presenting other types of output. Oh, okay. Pre-answered? So
I'm having a proliferation. I've got some
okay, population cannot be resolved to a type. Okay, so let's go see. Okay, my hypothesis is, so double click on this thing. Double click on that. Okay, and it looks like, oh, it's here. So scroll up so I could see this. So you don't have a thing. You have to do, count.
You see, that's still not there. What have I done? So that belongs in, I haven't named.
Then to get rid of those errors first. So count infective. Yeah. And then begin paren, end paren. Yeah. Okay, good. And so first of all, let's try rebuilding it and then see what the problem says. Okay, it's happy. Okay, sure. It probably didn't have the autocomplete because you didn't have the name yet processed. Okay, so because it wasn't able to do the build, it wasn't able to do the autocomplete with the appropriate name. Okay, so we should have seen when we ran that, we should have seen up here a chart of the number of infective. People see that? Okay. People okay with this? Okay, so now we're going to go into to sort of totally new territory with this. Okay, I want to create a histogram of something that's static. Okay, this will be another little challenge. Build on something we've seen before, but be a bit different from it. I want to create a histogram of the number of connections that people in the population have. How do we do that?
We're going to add a histogram data to name.
Okay, so good call. So in analysis, we want to add histogram data, and this is going to be called degree centrality histogram data. So if they like that, it's going to be showing the number of connections that people have. And then I want to add, more than that, I want to add a histogram. Not just a histogram data, but a histogram chart.
Histogram 2D data?
No, histogram data. Just above histogram 2D data. It's just the what above that?
Got it. It's just above histogram 2D, not histogram 2D data. It's rough. This one.
Yes, you want histogram data and then histogram as the chart. Yeah. Okay. 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 So, folks, we're going to have this chart be degree centrality. It's going to depend on that data. Okay. So, how do we have the chart depend on this data? So, add histogram data. Okay. And we want to make its title be degree centrality. Yeah. Okay. And what do you think the histogram data needs to be? It needs to be the appropriate data source. Okay? Is it called smart data?
That's the name of the data, yeah.
Yeah. Okay?
All right.
People okay with that? Okay. So build, make sure it's hunky-dory. Okay? Who needs help? Okay? Make sure this is hunky-dory by building. Okay. Now what we're going to do is we're going to go and populate this data. From where are we going to get the data from this histogram? This is new. We haven't seen this before. Good. It's going to be person level. We're going to be displaying this histogram over the population. Where can we go systematically through the population, member by member, and examine their characteristics? Okay, we could do it with item, but that's not going to provide us a useful way to do it. We're going to actually need to do it instead at a different place. And there's several places we could do it. We could declare an event to go off at the initial time of the model, time 0, or we could put it in on startup. We could, if we were willing to wait to the end, we could do it at on destroy at the model, then it wouldn't be visible. So let's do it on startup. Go to main and on startup. So startup for the whole model, we're going to loop through the population, and for each of them, we're going to put their data into the histogram. Okay. Great. So I'd like to go now and go over each person in the population and add their degree centrality, the number of connections they have to this data. How would I loop over each person in the population? A for loop, okay, especially those who are in the Java tutorials. We saw this yesterday for a for loop. How could I say, I want to go through each person in the population, giving them each the name P. They're each a person. How do I do that? For person P, and then there was a special character, it was colon, and then population. For person P in the population, now we want to do something which is going to have a name, and then if we have a given person P, what do we want to do? We want to count their data. Okay, so we want to add their data to the degree histogram. So I'm going to say degree centrality histogram data. I'm going to tell, hey, you data source, add this certain data item. What's the data item I want to add to it? P dot get connections number. Okay? Get connections number. Yeah, I'll put it on the big screen. So we already had this there, and now we're going to put for each person P in there, degree centrality data dot add P. This is the person. We're going to get the number of connections they have. Now note if they have several networks, we could actually say p.socialnetwork.get connections number, p.sexualnetwork.get connections number, p.needle-sharing-network.get connections number. But here, we'll just ask for the default one, the connection as shown by connections. Okay? Okay. Anyone need help with this? Who needs TA help? Okay? Should we run it? Should we compile it first? Let's build it. Build early, build often. Okay? Okay. So let's go and build. Okay? Okay. Okay. So here's the number of connections that they have shown in this histogram at the top. If we impose different network structure, we would see different histograms there. Okay, so that's a type of data collection over a static type of data collection over the population, in this case undertaken at the initial time. People clear about that? Are you comfortable with that? Now, yes.
Why the choice of the name degree centrality?
That's the name used in social network analysis to refer to the number of connections a person has in a network. It's a technical term used in social network analysis. And it's increasingly used in epidemiology, in areas of epidemiology that use social network data, sociograms. Okay. Okay. So here we see a depiction of this static data. Does anyone need me to show anything about what I've done before we go on to the next sort of data?
It doesn't matter if our colors are different, does it?
No. So I'll go on to this data. One thing we should have done, folks, if you did that and you ran that, you notice that if we went and we looked at this degree centrality data, here's information. These histogram data are dynamic objects. So you could see here that they'll have information on them. And if we went to Excel, for example, and we went in Excel and created a new sheet, we could dump the data from this histogram, which would be referring to, gives the CDF, the cumulative distribution function, as well as the PDF, the probability distribution density function, and as well as some basic descriptive stats on it, such as the standard deviation, the mean, the minimum, the max, etc. Okay, that's a useful thing. Same thing with this. You could copy this chart and you could export that as well. Okay, so at a practical level, those are available for exporting data from the model. Okay, but let's continue on here. Yes.
Can you do the same for a text file?
Sorry?
The information from the simulation and after that paste that in a text file?
So in other words, could I? Not sure what you mean. You mean could I go like this? Could I go like that? Yep. 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 Okay. So let's now continue on for additional types of data. Let's go and let's record. So again, this is cross-sectional, but at a certain time. I'd now like to implement a what I call a flow statistic. How many people have gotten infected within the past week? How many people got infected in the past week? The infected case count for the past week. How would I do that?
So we need to create the variable.
Okay, we need to create a variable. Good. That's a great start. Where would that variable live? Could live in main. That's good.
Kind of variable.
Some people would say, well, maybe it should be a static person variable. That's a little bit more advanced than put in main. So this is going to be a variable, and we'll add it here to main. Yeah. So what are we going to count? Let's call it count infected case count for week, or infection count for week. Infection count for week. It's actually for the current week.
Oh, yeah.
Okay. You could say for current week. I kind of like that. For current week. This is the week that's underway. Okay, what's its initial value going to be? Okay, 0. Before we count anyone, it's 0. What sort of variable is it going to be? It's a count. It should be an int. Okay, wow, you folks have come a long way. Great. Excellent. Okay, folks. So what sort of things are going to change this variable? Give me 2 sets of things that would change this variable. What would make us think that it should take on a different value? Somebody gets infected. Okay, so that's one. What's another one? Okay, this is counting the number of infections that have occurred, though. We're not counting the prevalent number, the number that are currently infected. We're counting the number that have gotten infected over the past week, the number of new infections that have taken place. So a new infection and then a what? A new week. Yes, the key things. Thank you. Okay, so folks, I'd like you to go to person, and where would we look for infections occurring? Enter the infective state. That's good. Notice we could have said, well, this transition, but then it wouldn't have caught these. Okay, that's a good question. So is it going to actually invoke this multiple times? Is the question. That's a good question. In AnyLogic 6, they would have certainly said, okay, that's not going to be invoked multiple times, and I would have thought that, but based on that thing we saw the other day, it kind of makes me wonder. It's a very good question. Okay, fine. Well, for safety's sake, we'll put it right here. We'll put it in these two things here. Each of those infections. Exposure once. Yes, we could do that. That's true. Nice. I like your idea there. Although now that would be coupled, and if we ever wanted to delay the time of the initial exposure, let's because it's a single line, let's put it in both these places. So we need to change that variable here. How do we need to change it? Okay. Well, let's for the reasons Maria said, until we fully are clear about whether the entry action is re-invoked when this self-transition occurs, and I really want to check on that, let's just put it for now with the transition in, okay? These two transitions in. What has to happen there? What do we need to do? We need to change that variable how? We need to increment. Where does the variable live? It lives in main. Main dot, it's called infection count for current week, and we have to increment it. So we do plus, right? People okay with that? And I'm going to put it in also for this initial transition here, okay? Okay, so that's one element. So I put it in both these transitions. Main.infection count for current week plus. Great. So we increment that. Okay. Where else do we need to set it? Well, if it's a new week, what does it need to start as? Okay, good. So how could we have something in our model that goes off every week? An event. Good. Exactly. So let's introduce an event. And this will be called weekly reporting event. Okay? I like to call it with the event at the end, so if we see it in a list of names, we know, oh, it's an event. Okay, fine. So what type of trigger is it going to be? Is it going to be a timeout, a rate, or condition? It's going to be a timeout, but the mode is it going to be occurs once or cyclic? Cyclic. First occurrence time 0, occurrence time 1. Great. So what does this need to do? Well, we're at the end of the week, suppose. So what do we need to do? Maybe we should make the first occurrence time be 1. What do you think? To report at time, well, no, we can report at time 0. That's fine. And it'll go off and report, okay, every 7 days. Oh, yeah, sorry, recurrence time 7. Thank you. The units of the model are days. Yeah, that's right. Yes, it does say you could set the units. That's really nice. So every 7 days, what are we going to do? Model time is set to be days, but we could set it there to be explicit. we need to zero it out. But before we zero it out, we need to do what with it? To print it out, right? Yeah, so we could say 7 days if we want to, and that's good practice to make it explicit. So here we could do trace ln to print this out. Weekly, or you could say count of new infections for past week was, and then print out, what do we print out? Infection case count for current week. And then maybe we want to print the current time. Something like this. So that's quite a mouthful there. So let me just print that out, and on sort of 2 lines. This sort of to be nice and consistent, I could just do this. Okay, something like that. Yours doesn't have to be in several lines, but I'm just printing it out so it fits on the big screen. It's also kind of a nice practice to have the concatenations appearing very clearly. Okay. Yeah, that's fine. Yeah. Okay. Okay, we're not done yet. Yep, very good point. We're not done yet. This needs to be there. And then we need to do what final thing? Reset it to be 0 equals 0. Okay? Okay. Great. Okay. That's great. Should we run it? Yeah? Sorry? This is the current time. It's returned by this function. We're calling the function. It's returning the time. So let's run this thing. And what's occurring in the background? Time is going on. It's moving on. We should be at the end of week 1 now. Okay. The count of new infections for time 0, the count of new infections in the past week was 1. Guess which infection that was? The original one, then 7, and then 6, and then 24. People comfortable with that? Okay. So who needs help here? Okay. Great. So, okay, next I'd like to accumulate that data. That's great, we're printing it out, but what if we want to accumulate it for exporting? How could we accumulate it, right? Natural question. Okay, folks, let's insert a mechanism for accumulating that data. This mechanism is going to be called a data set, and it lives down here in the analysis area. We put it into main. And this will be infection count for current week DS, I'll call it, for data set, or you could call it data set. I'll call it data set. AnyLogic folks seem to like to call it DS, judging by their models. Okay. And then we can choose update data automatically at a certain time. But I think we're going to not do it. Yeah, you can make it 1 million latest samples and eliminate that. But let's do not data update automatically. I'd like to show you how to insert data into there yourself. Okay? So we're going to do not update data automatically. And let's keep up to some large number, 100,000 of the latest samples. So it's not a practical barrier. Okay? Okay. So you notice if we say do not update automatically, we're not going to have to put in the vertical axis value. You note, however, it will timestamp it automatically. So let's go to the weekly report. And in the weekly report, let's insert here into this data set. Infection count for current week data set dot add, and we're going to add the item to be put in there. And what's that item to be put into the data set? Well, just before it's zeroed out, we'll insert the infection count for the current week. So now our event handler looks like this. This thing printing out the count of new infections for the past week, and then we're going to add that variable to the data set, and then we're going to zero it out. Question? It's automatically like an array, this data set. It says added in, it puts it at the end of it.
So I could put in the time also?
It's automatically timestamped. So a data set.
Something else like that I wanted associated with this.
Right.
So that I would just add the other variable that I wanted in the data set
data sets are conceptually like a single dimensional array. So if you wanted two sets of data in parallel, sort of with pairs, I would do a different data set. Okay. Yeah. You could do multiple data sets, or you could use your own custom structure. AnyLogic does also support a variety of extra collections. It's just data sets have a variety of extra features that they offer in terms of easy export and easy writing out and that sort of stuff. So they're particularly handy for if you can use them comfortably for your task. I'd advise using data sets because they're things to allow them to be printed out easily, or to add one data set into a two-dimensional data set for a 2D histogram or stuff like that. And so I'd say they have a little bit of extra flexibility, but it's not really that big a constraint because you can always fall back to a multidimensional array, or you can always fall back to a different sort of data structure, like AnyLogic has essentially dictionaries that you could put things into or what have you that are supported through what are called their collections, which is supported in the general tab. You can add a collection in, and that's also pretty good. But a data set has just, among other things, charts know how to deal with data sets really easily. So, okay. Okay, folks, so we should be able to run this. Who needs help here? You mean this thing? Okay. Okay, that's interesting.
I built with no errors, and
yeah.
Then I'm going to go run, and it says this.
Oh, okay, that's interesting. So, it's having a problem with the data set here. Okay. You can see it's saying something about the data set here. So, could I see the data set?
Of course.
Okay, so the data set here is, so my hypothesis, there's something about the initialization. Cyclic, show name, trigger type, mode, cyclic, use calendar dates. Oh, sorry, I'm looking at the wrong thing. I wanted to look at the data set, this guy. Okay, do not update automatically. Yeah, that's right. Oh, it's just because it's too many samples.
I was wondering.
Yeah,
okay.
Make it 100,000.
Okay.
There. Yeah. Okay. Great. Okay. Okay, folks. So if you run this, you should see something like. Do you need that still up there, Priyasri? Okay. Okay. Here we should see a data set that has these sort of items in it. I just clicked on the data set representation. Okay. And now you can right-click on that. You can do copy. Right-click on it, copy. And then you could go to Excel and you could go paste it, for example, and it will paste in the time and the value. Is that okay? People okay with that? Okay. So here we have a data set that's capturing a flow statistic. I call it a flow statistic. It's the number of people flowing from the uninfected state to the infected state, rather than just a stock statistic, a cross-section at a given time. Does that make sense? Okay. Okay, let's capture a few more types of common statistics here. Let's look at individual level longitudinal data. So let's go down to the level of the individual here and insert something that's the count of time that they've been infected.
What are you inserting?
In person, count of times that they've been infected. Oh, okay. We should add waning immunity for this, but or the time of infection, or let's make it count of time. Count of time infected. And to make this more realistic, let's add in waning immunity. Okay. So to add in how do we add in waning immunity? We could make a transition going from recovered back to susceptible. Okay. And let's add in immunity that wanes with a rate of 0.05. Excuse me, 0.02. 0.02. Okay, so this would be waning immunity. Okay, so waning immunity. Okay, so first of all, let's run this. So this is a rate of 0.02. So I'd like you to add that to try running this. Okay. So what we've just done is we've added a rate of waning immunity. So we've added a transition from recovered to susceptible with a rate transition of 0.02. Okay? And we've added a variable called count of time infected. What sort of variable is that going to be? Is that going to be, what type is it going to be? A double, an int? It's a count. Count of times infected. Sorry. The count of times infected. Sorry for the misspelling. It's an int variable, and it's going to start at 0, all right? Okay. So now we have this waning immunity with a rate of 0.02. And let's run the model. And now we should see. Oh, nobody got infected that time. That was it happens indeed. Okay, and now we have the infection spreading, but people, by and large, it tends to sort of peter out after some period of time. So that's fine. Okay, so this is count of times infected. I'd like to increase the population size a little bit more for this statistic to be interesting. So where would you go to change the population size? Population, yeah. Make it 1,000, sure. If we had more time, I'd add a parameter and have it be examined in different scenarios. Okay. Yes.
We don't yet have. We're not doing anything with that
No, we're about to do that. Okay. I'm just trying to keep infection endemic. Okay, fine. Now it'll be more interesting. Okay, so I made a larger population size there. Okay. So now what I want to do is, so we have a count of time infected. That's an individual longitudinal statistic, something that'll be hard to accumulate within an aggregate model, but we want to actually maintain it. So where would we change that? Anyone? Where would we modify that? Entry action to the infected state. Yeah. Okay. So here. Yeah. Let's put it in the transitions in. Thank you. We should really get resolution on that. I mean, coming into the boot camp, I would have been confident that that entry action would not be executed by that little thing, but I need to do some experimentation on that. It probably is not, but probably the rates are simply recomputed. But again, I need to be sure, and this is the safe way to do it. So we want to increment the count of time infected, and conceptually when someone comes in. I much prefer to do it within the entry point, and all it would take is about a minute of experimentation. Okay. Great. So the count of times infected. Okay. So those are at an individual level. Okay. So let's go run this model now. And I'd like you to dive down to level of individuals and confirm that this count of time infected is being maintained. Yeah. Okay. So person a histogram, which will be updating dynamically regarding the count of times people in the population have gotten infected to this point. Okay? How do we do that? Suppose we want a histogram that over time updates and shows this.
Before you do that real quick, is there a way to click on an individual in the aggregate when you're running? I just realized I couldn't find an agent that was changing, so I was trying to check that my count was working.
Right.
Can I click on an agent?
And find out who it is?
Yeah.
Yeah. How do we do that? Folks, people in the room, your knowledge should be such that we could do that now. How do we click on an agent and have it tell us their name? Tell us. Good. Okay, so let's Kristen, let's do that. So we'd like to go handle the on-click for the person. Now, I'm going to do it in the shape body on-click, just because I'm actually, I think that'll be more reliable. So I'm selecting their shape body over here, and then on the on-click handler, what should we do? Get it to print out what? Okay. My name is, yes, under advanced. My name is this. I've contaminated you with computer science speak. Okay. So we should be able to run this model now and click on a person, and it should be printing out my name is such and such, right? Right? So that's root population 40, and then I could dive down and go to root population 40. They've been infected one time so far. By speeding things up, now they've been infected several times. That's great. Okay. Okay, folks, so how do we have a histogram that periodically is updated with that longitudinal data?
Well, in Maine?
Okay. In Maine, yeah. Histogram data set, yeah. So this will be individual infection count histogram data. Count histogram data, right? And then let's add in a histogram chart, right? A histogram chart. And what's the histogram data going to be? Let's give that a name. Let's call it individual infection count. And let's call it histogram, right? Individual infection count histogram. And then let's add the histogram data. And what are we going to tell it to use for its data?
Individual infection count histogram data?
Exactly.
So we need to make sure we get that data.
Yep.
So that's the data.
Okay. Well.
What's happening?
I pressed the button. My computer was slow in responding, presumably partially because of the video encoding. And so I pressed the button in a fit of oversight. I pressed the button many times. It had about 10 items of histogram data, I think. Wow. Keeps on adding them in. That's exciting. Okay, let's go back to that. That's neat. Okay, let's go delete them one by one. There we go. You folks don't have to worry about this malady. Wow, look at all those. Okay. Time to make the donuts here. Okay, so add that in. And then I'd like you, and then what's the final thing we have to do with that? We have to link it up. Yeah, we have to conceptually link it up, right? Okay, come on. Okay. So how would we go link that up?
In the histogram data itself, you have to add the values?
No. Well, yes, you'll have to add them to that, but how would we add them to that? Where and when would we add them to that? Because it's being updated over time, right? So this is individual infection count, and where would we? So when would we add this in? Well, periodically we can get the infection counts. And what could we do to implement that periodically? Can anyone tell me? Yeah, we could use the weekly event, for example, right? Okay.
Sorry, for the data update, do we want to do not update data automatically or update data automatically?
That's a good question. I would say no, we don't want to, because there's no one formula we could give that would tell us what to put into there. Okay.
Okay.
So count histogram data. For some reason, my autocomplete is no longer working, so I'm going to actually. Not sure what's. Oh, that's yeah, but actually, it's like the key is stopped working here. So I think it's actually something maybe about my virtual machine in which I'm running this. I'm going to deal with these matters arising. Okay, so folks, what I'd like you to do then is to create that in that weekly event. What has to happen to populate that data set? In that weekly event, how are we going to put something in that data set? we're going to need to put data into that data set every week because we want to see the latest sort of set of infection correlations. So how are we going to do that? Okay, engine for the event, yeah. Well, what with person data? We're going to have to go and loop over the persons, right? And add for each of them their infection counts in, right? But maybe there's infection counts already in that data set. We have to do something with them, don't we? So, sorry? Well, yeah, we're going to have to reset them every week, the old counts, because we don't want to use any counts that are already present, right? Instead, we want to only use new counts. So, so in other words, here, we're going to do a big for loop. Yep. My virtual machine is acting weird. You're in the weekly reporting event. Yep. Yeah. Okay. So in this weekly reporting event, we need to. Okay, my virtual machine is really giving me trouble. Sorry, I'm running Windows on Linux, and I need. Okay, here we go. So I think I'm back in action, and let's go down to this. Okay, no, I'm not. It's still exhibiting problems. Okay, Priyasri, do you have your machine? Are you following this along at all? Oh, wonderful. Okay. Okay. Well, yeah, we're both exhibiting this function here. Okay. Great. Okay. Well, I've got a workaround, but it ain't pretty. Okay. So let's go to the weekly reporting event. We're going to need to go to that new variable we created, which is the individual infection count report, and we're going to need to tell it reset yourself. So this is in the code here. Individual infection. Oh, it's not processing my keys correctly. Okay. Thanks. If that would be possible, I've never seen this sort of issue here. Yeah. Yeah. Okay. Thank you. Sorry? We're supposed to be able to. Okay. Yeah, that would be ideal, but individual. Yeah, it's not even allowing me to do backspace. This is the most unpleasant. Yeah, we can take a break. 5-minute break. Okay. Sorry? External keyboard might work, although it seems to be exhibiting a dysfunction with my mouse as well. Okay, that will be great. That will be great. Thanks. Gosh.
Now the problem is you can't record on this one.
No, I know. I can reboot the Windows here. It'll probably be just fine. And I'm glad to do that if need. That might be the most expeditious thing. Just for now. Okay. Okay. Yeah, it's ignoring my arrow keys. Okay. Okay. We're gonna have to close this and get out of this. I think I'm gonna have to. It's something about the virtual machine. I think that's not handling keys correctly. Come on. Okay. So I'm going to leave any logic. Come on.
Do you have any Logic 6.9 installed in your machine?
Yeah.
If by chance the recovery doesn't work out, I could log in safe mode but like safe mode.
No,
not,
it's not gonna.
No,
I
I
wouldn't.
can actually run in the safe mode, then save
Yeah.
the things in my drive and show them from this computer. Or
Right.
But then it's not like capturing the entire image. Safe mode shows things a little distorted.
Indeed,
So it's not
indeed.
safe. So somehow I have succeeded in retrieving my things into this drive, so that if it doesn't recover, I can use probably your machine.
Right, right. Yeah, but my machine. Yeah.
But your machine is also giving trouble.
It's okay. So I'm gonna save this. Okay.